You're listening to the Common Descent Podcast. Hello, Will.
Hello, David.
And hello, Chris.
Hello. How are you today?
Good.
Quite good.
And hello, listeners. We hope you are good as well. Welcome back to our Common Descent Spotlight mini-series. In this series, if you've been listening, this is part 4, then you will know that what we're doing here is changing it up from our normal setup where we discuss scientific topics and instead focusing on scientific people in our favorite field of science. For this run of this mini-series, if we do more in the future, we have chosen the theme of invertebrate paleontology, and today we are joined by invertebrate paleontologist Dr. Christopher Ma. Hello, Chris. Would you mind to introduce yourself?
Certainly. A pleasure to be listening or to be presenting. I'm a curator, or not a curator, but I'm a research associate at the National Museum of Natural History. I work on the evolution and diversity of both living and fossil sea stars, which is a fairly narrow band of research. I focus mainly on living sea star species, but I've done my share of fossil taxa and exploring the long evolutionary history of sea stars. And so calling me a paleontologist is fine on any number of days. So.
Wonderful. Well, then you qualify to be here, and we're happy to have you.
I sure hope so.
Now, we understand that, amusingly, just like any group of animals, the sea stars have a scientific family name, and they are named for their shape from the root word aster. They are called asteroids, correct?
Correct. Yes.
And bet that leads to all sorts of confusion.
Yeah. So Asteroidea is the name of the class of organisms I work on. They go by common names as well, sea star and starfish. Asteroids is, of course, a term that everyone thinks about when they envision giant, massive rocks hurtling through space. And for some reason, people think that it would lead to confusion if we were talking about both starfish or sea stars as asteroids. So we made up 2 other common names to make sure that they were clearly labeled. And so there are now people, factions, if you will, who get into very strong disagreement about whether sea star or starfish is correct, and all of the words are synonyms. So as long as you're not confusing brittle stars with sea stars, then that's fine. Unless you work in the Paleozoic, in which case there's more sort of gray area because those 2 classes of echinoderms are closely related in the Paleozoic, and it's difficult to tell them apart. So that said, either any of the terms, sea star, starfish, asteroid, are all acceptable in a common sort of name sense. So
I can definitely vouch for your statement of regardless of which name you use, people will, because at the aquarium we have a touch pool with some sea stars in it. We go with sea star because the fish part is not, they're not fish, but we get people all the time who will be like, oh, is that a starfish? We're like, yeah, you can touch the sea stars right here. And they're like, oh, I'm sorry, did I say it? And it's like, no, you're fine. It's just, we use that one here. That's just what we do here.
Well, I've found that in recent years with education, sometimes the correction becomes as much of a distraction as the terminology itself. Because in education, of course, you have kids and they don't know any better, and you don't want to confuse them with the term fish as opposed to sea star. Mm-hmm. The truth is that the term fish, starfish, was actually a word that was used in the English language before the term sea star was.
Yep.
Mm-hmm. And frankly, the oldest word for sea star is actually an astronomical term, not a nautical one. So there are all sorts of things that just etymologically don't make any sense. So I've just decided it's fine, whatever works for you, as long as you understand that that these are echinoderms. They're not vertebrates. And so educators, I appreciate the term using sea star to avoid confusion, but with seasoned professionals. In fact, one of the most seasoned professionals in my field named her book Starfishes of the Atlantic. So it's used by authorities in many ways, and no harm, no foul. But I certainly sort of understand that some people want to make sure that things are labeled in such a way to avoid confusion.
Yeah, well, these names are hard to dodge. I mean, when you get to like jellyfish, there's not really a great secondary name to use in that case. So yeah, you just have to roll with it.
Exactly. I mean, there was a period in the 90s when everybody was adopting like terms to reverse all of the words. So like hagfish became sea hags and jellyfish became jellies. And everybody thought that was part of the like the sort of political correctness movement that was going on at the time. And I'm like, jellies and hagfish don't have any, political gain. That's, there's no reason why you would want to call them that other than certain levels of accuracy within education. Calling hagfish is fine, and it's certainly not something that resulted from politics. So very, very strange. Anyway.
Yes. So let's shift over to talk about a little bit of research. When you're looking at fossil sea stars, fossil asteroids, what sort of research are you doing?
Okay. So within the sea stars as a group, you could say that in the geologic scale of things, there are Paleozoic stellarazoans, and then there are post-Paleozoic asteroids. And so I make that distinction because modern sea stars belong to a single lineage. Everything that you think of as a sea star is essentially modern. Things that live in the Paleozoic are actually bizarre forms that sometimes show closer relationship to brittle stars rather than to modern species. And so my work focuses mainly on modern types of sea stars and their relatives. So there are lots of different kinds of fossil sort of modern sea stars. The Cretaceous rocks of Europe are filled with really gorgeous kind of cookie stars that look like Christmas cookies and biscuits. And they were formerly members of shallow water seas in the Cretaceous, roaming, while there were like giant dinosaurs roaming around on land. These sea stars occurred in kind of shallow water seas in the mid part of the United States and in Europe, and in what's called the Cretaceous chocks, places where there was a lot of calcium carbonate. And so so these are the kinds of sea stars that I work on. Their living relatives, the Goniastridae. This is the family Goniastridae, as well as other sort of modern sea star groups. And so I look at modern evolutionary events that are reflective of their diversification. So in other words, how you get so many different living species of sea stars in certain areas, like the deep sea or in the tropical reefs, or in the Arctic or the Antarctic. So I try to look at how many there are and the underlying reasons behind it, as well as historical reasons that might be associated with it. A lot of my work right now focuses on just essentially describing and counting the number of modern sea stars. So even though I do a lot of work, I have done a lot of work with understanding the underlying history of sea stars and starfish. Right now, a lot of it is very straightforward in that I'm going around to different museum collections and finding representatives of new sea star species. So in other words, to put a tree of sea stars together, you kind of need to know where all the branches are. And to do that, you need to find, taxa that branches on the tree that haven't been put there yet. And, and so my work tends to be collaborative. I work with people that are both paleontologists and molecular biologists, and I work at describing new species so that those scientists can work with me to kind of unravel the mystery of how they're related on these big trees, and then understand the evolution of sea stars in the big picture, and so we start from species level stories and we go all the way up to understanding the evolution of sea stars at the family or class level, the underlying diversification of all the sea stars since the modern sea star lineages developed since they evolved. And so a lot of them are thought to have survived the great Permian Triassic extinction. And so, there are lots of questions. What survived? What different kinds of organisms were present? What kinds of sea stars, in other words, were present early in that diversification, right after the great extinction? And, and which ones might still be around today, if there are any. And, and so understanding some of the more bizarre forms of, say, deep sea stars sometimes has a direct tie to that early event, and understanding molecular data has a direct relationship to understanding diversification patterns inferred from paleontology. So I tie it all together by looking at the modern forms and trying to integrate, where all these disciplines overlap. And it's not always easy, and and certainly it's evolved over many decades. But I do everything from looking at species from museums to working with Okeanos Explorer, going out to sea and watching some of these rarely seen starfish in their own habitats, and that gives me insight into their biology from a fundamental level, but also from a way that allows paleoecologists to look at their life modes and say, oh, well, that was significant in the grand scheme of things. So it all comes together, and it gives me an excuse to go all over the world to study starfishes. And I've actually been to all the continents now, so everywhere from Africa to Antarctica to Asia. Of course, there are no echinoderms on terrestrial and freshwater habitats, so I tend not to go to those places. But I have been to sea several times, and sometimes at some length. I think I was in Antarctica for about a month or so, and I've been to the Aleutians for about 3.5 weeks or so.
Oh, very nice.
I've done everything from field work in limestone pits in Florida, where I sweat out what seemed like a quarter of my body weight. Yeah, oh, it's lovely, isn't it?
Yeah.
To doing submersible work off the Hawaiian Islands. And of course, I was the voice on Okeanos Explorer.
Very cool.
Last July in 2017, where I was narrating, their ROV from the ship, and providing a sort of narrative on all these different kinds of sea stars as we were discovering them. But of course, I'm well-rounded, so I know a little bit about everything in the deep sea, especially. And so I spoke. We discovered a really exciting field of glass sponges. We saw fields of carnivorous sponges, as well as many species of starfishes, which doing things we had never seen before. And as I spoke today,
very cool.
I was just talking to Okeanos Explorer today, and we just seen new feeding observations in the Gulf of Mexico. So discovery is happening. You can go to Twitter and see those things right now. Hashtag Okeanos and Gulf of Mexico, Richardson Ridge, and you can see some of the discoveries that were made on Twitter, or were made on the live stream, but see them on Twitter today.
Very cool. I do want to ask some more about the living starfish that you're looking at. But before I get to that, I want to make a question about the fossils. In this series, we've talked to a lot of people who study organisms with shells. And organisms with shells fossilize extremely well. What is the fossil record of sea stars and starfish like? You're trying to look at this whole history over 200 plus million years. You need a good sample size for that.
Yeah, working on sea stars as fossils is a challenge. Certain groups fossilize more, have a propensity to fossilize more than others.
Right.
So the family that I was talking about, the Goniasteridae, they have really strongly developed skeletons, and so they tend to fossilize more readily, or at least the ossicles that make up these are the skeletal components that make up their skeleton. They fossilize more readily, and this is kind of a mixed blessing, because only rarely do you get an intact sea star as a whole fossil. More commonly, you tend to get small, sort of lozenge-shaped bits left of their skeleton. And in fact, when I was working in Florida that time several years ago, there were places where you could literally go and get thousands of tiny little ossicles of sea stars from, I believe it was the Oligocene. And, and the problem is you don't have a whole body fossil to go along with it. So in many ways, it's kind of like studying vertebrates because, you find lots of bones, but you rarely find one completely intact.
Right.
In contrast to that, I was just in Japan, and, there's an extraordinary Lagerstätte there from the Miocene where deep sea asteroids are preserved in this very fine shale. And so the specimens there are extraordinarily preserved, and they're deep sea animals. And so they've found many, what would otherwise be very fragile bodied sea stars and echinoderms, but completely intact. And you can see them, they're almost like looking at modern examples, but just short of having complete details. So there are animals that are called slime stars, for example, in the genus Hymenaster. And I discovered one of these from this fossil deposit in one of the collections in Tokyo. And, and all the details were there. It was startlingly well preserved. And there turned out there were several of them. There were several what's called pancake urchins. You can see living examples of this on the Okeanos Explorer video feed, but they're essentially sea urchins in the family Echinothuridae. And they, when they bring up to the surface, the water evacuates from their body coelom, and so they flatten out, and hence the term, pancake urchin. But they have little walking legs around the edge, and they have sharp spines, and they're actually toxic, or venomous rather, and you can get stung pretty badly by the living ones.
Oh yeah.
The fossils, there were some that were found that they preserved a lot of the significant details perfectly, and they're just wonderful. They're wonderful fossils to look at. And so, I've been working with the Japanese to try and get these specimens published, and, whether I do it or whether one of their students does it. But I've been trying to help push along that work. And there's some remarkable animals that they've encountered there. So, and because I work on the living, I'm able to sort of integrate what I know about modern animals with these well-preserved sort of deep sea fossils. And so that's often what I do, is I try to incorporate what I know about living animals to a lot of the fossils that I encounter. And in fact, I often observe things alive that are evocative of Mesozoic species. So some of these goniasteroids that I'm talking about, they're essentially kind of cookie shaped. I mean, they literally look like Christmas cookies. They're hexagonal, and they're, and they have a thick edge around them. And that's what the Mesozoic forms looked like, and so sort of seeing the dynamics of how the living ones lived, provides us with insight into how the fossil ones might have lived. As one of the geological disciplines teaches us, uniformitarianism. The key, the past is the key to the future, or present is the key to the past. The processes are all the same, one hopes. And so that provides at least the basis for understanding the biology of some of these species through time. So a lot of I try to balance out what I do, taking a holistic approach and incorporating the different perspectives that I have at my disposal and into one focus.
Great.
The emphasis on needing to understand the modern to understand the past, probably I think one of the biggest unknown aspects of paleontology for most people who aren't studying it, is that there's heavy study on modern groups, because otherwise you can't form a complete picture in either direction if you're just studying one or the other.
I agree.
Now, speaking of that, actually, I wanted to ask, so obviously you're doing a lot of work looking for sea stars, living sea stars, not only in museum collections, well, very recently living sea stars in museum collections, but also out in the field, which in this case is the ocean. Where do you go to look for sea stars?
It depends which sea stars, but the most recent field work I've done has, for example, been with the NOAA research vessel, Okeanos Explorer. But I also am kind of the contact person for a lot of oceanographic research vessels and deep sea research expeditions. So I don't even really need to go out to sea as much anymore, because typically they have someone who's very good at collecting and preserving and bringing things back.
Okay.
And so it's not necessarily required for me to go out to sea with everybody all the time to bring all of it back, personally. It used to be when I was younger, there were specific reasons why I needed to go out, which would involve sort of getting the specific taxa that I needed, or working on, particular species that you needed to take DNA from, or what have you. But because a lot of what I do nowadays is focused on discovering essentially new nodes or new species, I literally sort of can go to museums or wait for other people to bring things to me. So I go to museums. I travel a lot to natural history museums where they have collections. And these are places where the samples from different expeditions are often housed in one place. And so, I can often wait for an expedition to be over for sometimes a year, and all of those specimens, all the starfish specimens from a particular place, might be accumulated, and so I can look at them all in one place.
Okay, cool.
So right, and so sometimes I go out with vessels and do personal, field work to collect things, but usually that's because I have a specific reason to go out with them, or sometimes because it's just because there's a need for me to be there. There was a molecular sampling trip that I went on with some colleagues in 2006 to Antarctica. And I was at the time, and still am, one of the few people that identifies Antarctic starfish as one of the only people who can identify them on the deck of a ship. And,
very cool. That's a marketable skill, right?
Yeah.
That goes on the CV.
Yeah, well, yeah, it's a mixed blessing, let me tell you. So I helped them work with those specimens and bring back correctly identified material for the work and the projects that they were involved in. But since then, it's just gotten to the point where, since I can't be in Antarctica all the time, I basically let them collect everything they want, and then they bring it back to me, and I identify it for them. And that's fine. So this is another point, which is that my expertise is actually not something very commonly encountered. So there are very few people that do what I do. There are actually more people who work on starfish fossils than there are people who can identify modern things. And so,
really?
Yeah, it's really kind of funny, but
wow.
Yeah, but there are, I think, 1, 2, 3, 4. There are 4 paleontologists who work on starfishes right now. And technically, although I'm one of them, I'm the 5th one. I work mainly on living things. And so, most people, if they want to know how many different species, an Antarctic starfish there are, sort of looking at the recent fine-tooth gradations between them, that's really more a question for me than it is for a question for the guy who works on, Paleozoic things.
Yeah,
right.
So it's often difficult because I'm the only one, and and some people, the paleontologists get by on general identifications and all that sort of thing, and they're good at it. But again, like if people are for what people need, like ecologists and deep sea biologists, they usually want to know like the names of specific taxa that they're encountering, and they might not be relevant to paleontologists at all. And so that's the kind of thing that I would know that I would help them with. So mainly I cater to, in that sense, I cater to ecologists, I cater to physiologists, I cater to biologists essentially. So there's a lot of overlap, but it's a very short list of people that work on specific groups. And I often joke that I was just at an Echinoderm conference in Japan, and there was me and 2 of the world's experts on brittle star taxonomy in one bus, and we were joking, maybe we shouldn't all get in the same bus in case there's an accident, because that would pretty much end all taxonomy in those groups, if something happened to us.
Mm-hmm.
So, and the sea urchin expert was with us too, and so it was like, oh yeah, that'd just be a big double whammy. So
I find it very interesting which groups, especially when they're like sea stars that are super numerous and we see them on beaches all over, but then they're just not getting studied much. That's very interesting.
Oh, that's true in ways you hit it right on.
So, as you mentioned before, it sounds like one of the really nice things that you're able to do, since you spend so much time looking at the living stars, is bring that ecological context to looking at fossils and to interpreting prehistoric records of these animals, which is a really great thing. Not everybody has time to, you can't do both. It's hard to be an expert in fossils and in the living at the same time.
Sure. Oh, yeah. Well, yeah, that's exactly right, because there are certain Cretaceous species that I've seen living examples of. And, and so sometimes living examples are the same, but sometimes they're not. And that's an important distinction, is trying to say, well, just because it looks like something in the past doesn't necessarily mean it was. And,
Right.
And even if it was, could it have lived this way? There are all sorts of filters that one gains from looking at things with a modern eye. So
Yeah. Cool.
So, out of the vast sea and the vast geologic record of invertebrate species and groups available to you, why sea stars?
To put it briefly, it's because sea stars have a relatively uniform body plan, but they show modification with different environments and different settings.
Mm-hmm.
So, I liken it to the way that action figures come with different suits, for different habitats.
Yeah.
The Batman suit for Arctic adventure, and you have the Batman suit for scuba adventure. You have
Right.
the Batman suit for, stealth adventure. Sea stars are the same way. They often have different adaptations for different environments. You have Antarctic ones, you have deep sea ones, you have those that live on muddy bottoms, the ones that can live on sand, the ones that can dig into unconsolidated sandy bottoms, the ones that are specialized for living, that live in the deep sea, in specific types of habitats. Some of them hold their arms up in the water to filter feed, and they have special adaptations that allow them to do that. And so that's why I really like them, is because they're really kind of a cool model animal. And you can look at all the different stories that emerge from this very familiar body plan, and yet they do so many different things in almost in a standardized and kind of modified, sort of superficial suite of changes to how they live. And and I've always been attracted to that kind of diversity, is just all the weird stuff that they do, and yet they're still sea stars. They're still recognizable as sea stars. So
Right.
I appreciate that part of their evolution. They're very good models for that. But and there are other, I could go on. There are lots of cool things they do that are on top of all of that adaptiveness, in their story, because some of them do very unexpected things. Some sea stars can capture fish. And in fact, it's been pretty well established, for example, that some sea stars can actually feed on mobile prey pretty regularly. There's a large monstrous starfish in Antarctica that has 50 rays, and it lives by essentially grabbing small krill and pulling them down and eating them. And so it's a crazy animal. I mean, I've fed them in Antarctica, and they're wonderful animals. And there's an interesting story to them on top of all of that. But that's one aspect, is that even though you've got species that live in an Antarctic habitat, nothing prepares you for, they feed on moving prey, So
That's fascinating.
there's all of these unusual tweaks that echinoderms, as a general rule, echinoderms have just so many bizarre solutions to problems that most animals have. That's one of the things that really draws me to them, is just the strangeness, as well as the nice model qualities, but to all of the sort of bizarre solutions that they made to solving or to optimizing their life mode.
Oh, this is one of those conversations that, as when we're finished, it's going to leave me spending lots of time on Wikipedia and YouTube.
Yeah, absolutely.
Learning and watching a lot about starfish.
Well,
Absolutely.
I can certainly help you. You certainly know my blog, and there's a lot of information there that corresponds to what I've been saying. So I can provide you with lots of background for all of that.
Yeah.
Wonderful. So, in addition to your research, your direct research and your journeys around the world looking for sea stars and things like that, You also do some online work. For example, you have a blog. Can you tell us about that?
Sure. So in 2006, I came back from a job interview and realized that although I was becoming relatively well known, I really wasn't getting the kind of, I guess, coverage that I really wanted to. People didn't know who I was. So I thought that the best way to not only give back what I knew to the community, but also to sort of have an effective outreach platform was to start a blog, which was quite the thing back then. So essentially to have a way to communicate all the stories that I was aware of, all of the little educational anecdotes, all of the information, well, even the Starfish Sea Star story, all of these things were things that I just wanted to put out there. And so the Ekaina blog was born. And it started out very small. It was a niche blog. And unfortunately, I had a number of really well-connected friends at Deep Sea News and other places who were very gracious and essentially piggybacked my blog along with theirs and made my name known throughout, the internet. And over time, especially during certain odd and bizarre events, my blog kind of took off on its own, which, for a niche blog was kind of interesting. Well, basically what I'm thinking of is sea pigs, because there was one day, yeah, I know, but there was one day when there was this Facebook quiz, which everybody was asking, because there was these bizarre pictures of an Antarctic sea cucumber, and they were talking about these things as sea pigs, and I forget the exact context, but they were just showing them as part of this quiz and describing them as sea pigs. And I realized then, because there was a spike in my numbers with one blog post where I incidentally mentioned sea pigs, that everyone wanted to know what they were. So I literally sort of spent the entire weekend gathering up everything that was known about sea pigs, which really wasn't that much. I wrote a blog about sea pig, and boom, you can look at the Google Trends, the term sea pig just spikes, just crazy.
That's fantastic.
And so is it correct and humble to take credit for that? Probably not, but I'm going to.
You earned it.
Yeah.
Ride that viral wave.
That sea pig hype.
Thank you. And then later on over the years, other people have kind of jumped on the bandwagon, including the famous Z Frank, true facts about the sea pig.
Yes.
And so I am credited in the back of that video, at the end of the video, as having helped them. And I was actually consulted by them on the phone regarding essential facts regarding that video. So
that's awesome.
So and I've written other, really blogs that have found their own niche. I mean, in the sense that posts became popular on their own. And so eventually it became relatively well known. And so in addition to that, I started tweeting. I started doing this on a more regular basis, and I realized that was kind of the way it was going to be. The regular blog posts, writing a whole thing every week, and blogs in general, the long form of social media, became kind of passé. I still use it for writing things, but it's really not something that it used to be. Blogs were the main communication for SciComm, and then Twitter became the established sort of standard. And so I still use the blog when I want to express or put something out there, that I think is worth a full column. But Twitter is usually, where I will promote the blog, but also answer questions and tweet about like moments or links or important things that I think need to get out there right away. And it's grown to a healthy, I think it's like almost 6,000 now. So some 5,900 followers, and Okeanos, of course, helped with that. And this helps, my general science communication mission, which is simply to bring awareness to people about echinoderms and sea stars and marine invertebrates and invertebrates in general, and try to demystify them, remove the fear, and try to make them, interesting creatures to people, who might otherwise think of them only as those ornaments
Mhm.
that they buy at Christmas time, or God forbid, those painted Santa Claus things that they buy from tourist shops. So I do my best to try and a lot of my general theory about this is that simply showing people images of these animals is enough to just get the word out regarding their existence, and the fact that they're interesting. Because something like a Brisingid sea star, which is a filter feeding sea star, nobody knew what they were, maybe 10 years ago. I mean, literally the number of people who knew what one was limited to maybe
Wow.
3 or 4 people professionally. And now, I can go on Okeanos and there's a dozen people, 100 people who know what that is. That might not seem like a lot, but that's more than what, it's a commonly referred to term. There are lots of people who know what that is. And the same goes for sea pig. It's still perhaps not recognized as a sea cucumber by everybody, but there are now more people who know what a sea pig is than before. And, something like Scotoplanes, which is the genus of sea cucumber to which a sea pig belongs, that again was an animal that was only known to specialists who had only read the scientific monographs, who had only ever seen the diagrams from these 19th century monographs. So a lot of my SciComm, I think, it's like a sea star movement. It's very small, it's very short, it's very gradual, but over time, I think it does get there. And I'm very happy with simply there was one time that I think I tweeted the term Loriciferan, which is a phylum, which is a poorly known phylum of animals. It's a phylum of animals, which is something that most people don't realize. And so the simple fact that I used the term and explained what it was, I would like to think that one of the thousands of people on my Twitter feed can now look to that and say, "Oh, I didn't know that."
Mm-hmm.
So again, one at a time, perhaps, but I'd like to think that maybe I've reached someone, and every little bit helps, I think. And again, like with every from a fossil perspective, I was probably one of the first people to blog about some of these weird Paleozoic echinoderms, helicoplacoids or Ophiocystioids. And I remember when I tweeted Ophiocystioids, I thought I'm probably the only person who's ever tweeted Ophiocystioids on Twitter, and I was probably right.
Yeah.
And Ophiocystioids, as it turns out, might well be that fossil kind of intermediate between sea urchins and sea cucumbers. So they are actually, even though they're kind of bizarre things that sort of seem more like a nightmare from a Cthulhu, storybook, they actually turn out to be phylogenetically quite important in the grand scheme of things. So things like that are what I like to take home as the little victories.
And on top of your social media, blogging and doing this sort of SciComm online, you also do outreach in person, don't you?
I have done outreach in person. I don't mind doing it. It's not something that I find as effective, mainly. I mean, I've done Scientist is In type events in the museum. I've done public talks for sort of these evening date night type things at some clubs. Sometimes there's a YouTube video of my giving a talk, which was part of a DC Nerd Night event, which went over very well, and I was very proud of that. I think I've only done that once, however. And I used to do outreach for the Monterey Bay Aquarium when I was an undergraduate, and so I've logged many hours talking to people and sharing stories about marine invertebrates. Essentially as most of my training when I was an undergraduate. And so, I've now moved on, and I'm the Scientist is In here at the National Museum of Natural History. When I do these little shows, I engage a lot of people. I was told once, I don't know if this record has been broken, that I engaged the most number of people at a Scientist is In session than anyone else in the 3 hours that people are on the Ocean Hall floor. So
very nice.
Yeah. So
Well
that
done.
just means that I've talked continuously for 3 hours, which again, that makes a blessing.
Yes, that one Will and I both understand.
Yes,
Sure.
yes, we do.
Yeah.
Fun fact for you, by the way, after you said it, I went over to while you were explaining, I typed very quickly into Twitter search. The word ophiocystioids has been used less than 20 times on Twitter, and they are almost all you, including the very first one. So you're absolutely right.
Nice.
I can sleep well at night then.
Yes. I can rest.
Congratulations. The Ophiocystioid Twitter reward goes to you.
I can only say amazing.
Very cool.
Do you get a lot of response from people on social media when you're tweeting about, sea stars living or fossil? Do you have any? What lets you know that you're reaching your audience?
I get the most response when I'm doing something that's being widely publicized, such as Okeanos Explorer. In fact, today, for example, I just got an email from someone who just literally wanted to let me know that she thought I was great. That
nice.
My call-ins to Okeanos Explorer, she felt they were very informative, and I guess I have a friendly tone. So, and this was a person who worked as a geology instructor, I guess. So, but I have occasionally gotten messages from Twitter, other Twitter people, as well as personal messages. Ever since my blog started, I've gotten some feedback. Personal colleagues and whatnot have told me that they very much like the outreach that I do. So I can only believe them. And and
of course,
there's of course, there are some objective means of seeing how far the blog has reached, all the numbers and metrics and such. But
yeah,
in truth, I don't know how widely affecting the blog and my social media are. But I take every small bit of feedback that I can get, and it all seems to be pretty positive.
Mm-hmm.
I rarely receive any negative feedback or any kind of negative pushback. I think the only time that I received an incredibly negative pushback on anything was during the time that I was debunking several of the Fukushima sort of starfish wasting disease myths that had popped up around the time. And so a little background, just a quick story, but that was essentially there was a disease epidemic hitting the Pacific Northwest coast.
Yeah,
right. I remember that.
Right, and so there were sea stars dying en masse. There were literally hundreds of them just dissolving into goo. Coincidentally, there had been a accident at Fukushima as a result of the tsunami that had hit Japan at that point. And so they had thought that there was a catastrophist or disaster website which was spreading misrepresentative information that the two were connected, and people were drawing that connection very spuriously. And so I got an invitation from Deep Sea News to write a post explaining exactly why the two were completely unconnected. And it wasn't, there wasn't any real contest there, because starfish wasting disease had been documented almost 2 years or 3 years before Fukushima even happened.
Yeah.
That's not even rocket science. It's just timing. And the pushback on all of that was just tremendous, because there were so many, there was so much hostility, to, sort of, are you a nuclear shill, or you're being paid lots of money by the nuclear industry? And I was like, no.
People don't like debunkers.
Yeah. Well, I was like, it's like the funny story that every scientist tells about being paid off by an industry. If I was being paid that much money, I'm sure not seeing it. I'd love to have more money for that, but no, and so, but the truth prevailed, and, and I think it's gone on, and, the starfish wasting disease story continues, and people are discovering more about what's going on there. But I played my role in that as well. I helped waylay some of the misinterpretations of the story some of my colleagues had inadvertently spread around, and I'd also done my share to break the story to people on my blog. So, and I still talk to people about bits and pieces of it, which I think have gone unnoticed. But I know a lot of the key players who are looking into that issue now. And so, I'm happy that, I could have, even if I was an incidental player in that whole story, I was glad to have sort of helped with it.
Absolutely.
Yeah. So anyway, that was the sort of the only time that I've gotten really negative pushback. I've gotten lots of good interaction.
Excellent,
for the most part.
Excellent.
Yeah.
Very cool.
So the last thing we wanted to ask you about, as we have been doing this series and we've been talking to a bunch of scientists, and as if people have listened to this series up until this point, they've heard us say this. We are doing these interviews over the summer, and the summer is a tough time to get hold of scientists because scientists are always going on trips. And you actually just mentioned this a couple times on this discussion. You just came back from Japan.
Yes.
Can you tell us a bit about what was your trip to Japan like, and as much about the fossil stuff as you can?
Sure. So this particular trip was partly to visit Japan for the International Echinoderm Conference, where I will be joining a team of paleontologists to write the new treatise on invertebrate paleontology sea star section.
Okay.
Which is a big thing for people who do this sort of thing. And so there was a big meeting of other people who will be writing their respective sections in the treatise. So, the echinoid people, the Paleozoic echinoderm people, so if you work on Egeo asteroids or all those other things, all those people were there, and they're all going to be writing their respective chapters in the treatise of invertebrate paleontology. So there's that. The museum that I visit. So after the meeting, I also went to the Tokyo Museum. Japan's essentially Japan's Museum of Nature and Science, their Smithsonian, if you will.
Mm-hmm.
Right.
And so their collections included many new species and many other taxa, but also one of the largest repositories of fossil asteroids in Japan. And so I'm continuing to work with a lot of them on this deposit of Miocene deep sea fossils, and so that was one of the things that I worked on, was to look at some of these fossils and to try and figure out what they are, and in the hopes of eventually publishing on them, or at least helping some of the people who have collected them to publish them or recognize them or deposit them in the museum. A lot of what I work on, again, overlaps with what they have as fossils. So, for example, there is this one, I think I'd mentioned earlier, a slime star. And,
right.
And so basically these are very delicate sea stars, and they have a gelatinous covering, which makes up the entire top surface of their body. And as a defense mechanism, they can shoot mucus as sort of a defensive projection. It's lovely.
Interesting.
Oh, cool. Yeah. That sounds great.
But they're really poorly calcified animals, and their body is made up of essentially a bunch of rods. They're kind of very poor, weakly skeletonized animals. Echinoderms are made up of an endoskeleton, and these particular sea stars have a very poorly developed one. And so among the fossils that they have in this collection are fossil members of this genus, Hymenaster. And so there are people in Japan working on that fauna. And so I was the one who actually identified the first fossil of that group of sea stars, and I'm working to try and get that published. Whether it's from me or a Japanese student, we're still kind of working on it. But that's a remarkable instance of preservation. And it was it was so unexpected that I wasn't even sure what I was looking at until, I literally, had them side by side. So there are lots of interesting things that I discover when I go on these trips, and visiting other countries and their natural history museums is often a rich source of, publication data for me. And so
certainly,
yeah. And so, because there are specimens that they have the specimens, but I have the expertise. And so you get the two together, and boom, you have a bunch of publications. And so, for example, I regularly visit the Paris Museum, the Muséum National d'Histoire Naturelle, and and they just recently brought back several collections from the Indian Ocean, from Madagascar, and from other places along the coast of Africa. And so I've worked on describing a lot of new species. I have a paper that's currently in review that should be published this year that includes 3 new genera and I think something like 12 or 15 new species from the Indian Ocean.
Oh, wow.
And I just published something earlier this year that had a lot of data from New Caledonia and among other places. And again, a huge monograph describing several new genera and dozens of new species. So, and then including a subfamily. So there are all sorts of things that in fact, and that last paper included also some comments on a fossil sea star that was in the Paris collections. So anytime that I've done work on modern sea stars, I try and incorporate what I know about fossils into it, so that that I sort of take that holistic approach, so that everything can be treated comprehensively, because there's a long history in science of biologists essentially ignoring geology and paleontology, and vice versa. You having paleontologists essentially ignoring biology.
Yeah.
And there's no reason to. So, it's just that there are people that just have these artificial boundaries. And so, it's just one of those things that I've gotten around.
Yeah, you're a liaison.
Yeah.
The paleontologists and what paleontologists call neontologists.
Yes, exactly.
Which is a word that only someone who's not a neontologist would use.
Yeah.
Exactly. So, yeah, and so do I have a bias? Yes, because anytime I see a sea star like on Okeanos, some living animal, I'll see it as, well, that's kind of a cool fossil that's alive. If I'll think about whether it has a fossil record or not, and whether or not what we're seeing might have relevance. So today, we saw what's called a Pyraniid, a sea star that has a lot of tissue covering its body. Those were recently discovered to be represented by fossils from the Triassic, which is really unusual because it's early in the Mesozoic. But also, it turned out that phylogenetically, molecular data taken from molecular extractions of different sea star groups shows them to be an early branch within a large group of sea stars called the Valvataceae, which is where most of the diversity of sea stars is found. So anytime you have new observations of animals like that, it's relevant, I think. And
Sure.
And so, or maybe for paleoecologists, or maybe just to clarify how they live. There were people who used to think those sea stars were only ciliary filter feeders, and it turns out they're probably predatory. And so, there are some people who have made entire hypotheses about the evolution of groups based on these sort of, early non-evidence-based guesses, essentially.
Yeah.
And people who would say, oh, well, they're filter feeders, but now, their close sister taxa are predators, and so there must be a shift between them. So that kind of thing is something that I'm trying to head off by providing real data on what a lot of these animals do in real life, as we see them alive in their habitat. So, which is something that a lot of paleontologists don't get a chance to do.
Very true. Very true.
Very cool.
Chris, this has been a whole lot of fun. It's been great to hear about your research. If our listeners feel the same way, where might they locate you on the internet?
Well, if you are on Twitter, you're welcome to find me at Echinoblog, ECHINOBLOG. And similarly, my blog on Blogspot is the same. I mean, if you Google Echinoblog, you'll get mostly me. I think there was a strange coincidental French blog called Echinoblog, but I don't know if it even exists anymore. But ignore that part and just go to mine, and mine will have a lot of stuff about everything from slime stars to weird Paleozoic fossils to just a whole bunch of stuff. The blog link can be found on my Twitter handle.
Okay, and we'll put the Twitter and the blog and all that in the podcast description.
Sure. Yeah. And I'd love to, hear from people if they have questions and other comments, or if they want to learn more about sea stars, especially. But I'll tolerate questions about sea pigs and but I mean, all the iconic deep sea animals, giant isopods and deep sea cephalopods and whatnot. I love all those things.
Wonderful. So if our listeners have questions and curiosities about deep sea invertebrate life, now they know where to go.
Absolutely. I'm not an expert in everything, but I do know I do know all of those experts. So
there you go.
That's the trick. That's how Will and I skate by.
Yeah.
Oh yeah.
Oh yeah.
Well, Chris, thank you so much for joining us for this episode. We really appreciate having you here.
I greatly appreciate your opportunity. This has been fun, and I hope that there will be another moment when I can come back and talk about whatever other topic might be on hand someday.
Wonderful. We hope so too.
If we ever have to do a Sea Star episode,
Yeah, we know the guy.
Yeah.
We know.
Well, if you're ever in Washington, let me know.
Yes.
Absolutely.
And listeners, thank you as always for tuning into this episode. If you like this series, let us know. All the usual social media places and ways to contact us. And keep listening because the series has not ended yet. And we hope you'll join us next time. Goodbye, everybody.
See ya.
Thank you. Have a great weekend or day or whatever.
Thanks for listening to the Common Descent podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.